Excellency, the Minister of Environment, colleagues and friends, ladies and gentlemen, it is a pleasure to be here, to be part of this first historic Cairo Water Week. We've heard some outstanding presentations already about the global dynamics of climate change and Egypt's leadership in moving forward with accepting, understanding, and reacting and leading some of the responses to climate change. What I'd like to do is to take a slightly different cut, which is to look at the region, to look at the regional climate and water risks, the ways in which the climate change is impacting and intensifying some of the age-old struggles that this region has encountered in its management of water resources, and some of the responses, both those that are being undertaken already and quite ambitiously and quite successfully, but not everywhere. So what I'd like to look at is the multiple water and climate challenges to begin with, how these interact then with climate change and responses and risks to these challenges within the region. First, I think it bears mention to note just how more serious, more dire the water stress in this region is relative to the rest of the world. A lot of the figures that I'll show you this morning are from a report that the World Bank put out. I'm currently the Director General of IMI, but one of my final pieces of work at the World Bank when I was Global Lead for Water Security was this work on scarcity in this region. And what we found was that it is absolutely true. The amount of population that live in water stress is so much greater here. Every country in the Middle East and North Africa lives under water stress, high or very high water stress. So where you see that 33% or so, 36% of the world's population lives in water stress, within this region it's over 60. Where you see that about 22% of global GDP is produced in areas that are under water stress, in this region it's over 70. So this is the overarching theme and challenge in the region is water stress. And the most obvious impact of water stress is the unsustainable use of water. And what we see here, we see that over 30% of the region's water use is considered unsustainable. And that's a rough estimate. Unsustainable is the idea that if you had a bank account, for example, you're withdrawing more than you're depositing. In general terminology, we think that if you remove more than 40% of the natural stream flow, you're in a situation of water stress. And we find that that applies to about 30% of the water usage in this region, up to 50% in some of the surface water areas. But a particular concern is the overabstraction and unsustainable use of groundwater. And we see that in this map here. This is the groundwater use, which we see very bright red relative to the rest of the world in this region. And the reason I think that we're so concerned with the overuse of groundwater is that groundwater tends to be the water of last resort for vulnerable populations. It's also the water that is most difficult to understand its usage, its dynamics, its recharge, and it is the water that is most difficult to manage, to govern, to track, and to take care of. So when we see this level of exploitation in groundwater, it is an issue of particular concern. We also see that the unsustainable use of water resources affects wetlands. And an extreme example of this, of course, is the Mesopotamian wetlands in southern Iraq, or the Arab marshes, where over the period between 1970 and 2000, those wetlands shrunk by roughly 90%. Now, this was a consequence of abstraction and a lot of dynamics in the country at the time, and we have seen some recovery since then. But it's a cautionary tale everywhere, because what we also saw with the contraction of these wetlands was an enormous amount of migration. This map is from the International Organization of Migration, the UN agency that tracks movement. And what it's showing you is that over 90% of the migration out of this area indicated that water scarcity was the number one reason for the move. It was the number one push factor, even in an area that we know had a lot of fragility concerns at the same time. It was water scarcity that pushed this migration. This was back in time a little bit, but even within the last month, we've seen water shortages in the city of Basra that have flared into social disruption at the same time. So this issue of ensuring that water is being managed sustainably, both to sustain the spaces in which people live, in order not to see push migration out of areas, in order to continue to deliver the basic services that sustain harmony within communities. These are very significant issues, and ones that we need to think about when we look forward to a time when it will be that much more difficult to sustain wetlands and to supply significant water resources, even in places where we already have the pumps and the pipes, the infrastructure to deliver water. The water resource supply is something that's of great concern. And a related issue to that, of course, is water quality. Because where water quality makes it unusable, the quantity is irrelevant. The more water quality diminishes, the less water quantity we have in effect. This map shows untreated household wastewater. The red areas are ones in which less than 25% of urban water, household water is being treated. And we know that water supply, sanitation, hygiene is in the top 3 risks to health in emerging nations. And we'll come back to this issue of wastewater as well. But in addition to the urban wastewater, where we're putting a lot of effort as a globe into water supply and sanitation, the risks increasingly from agriculture and industry are becoming very threatening. And the risks to water quality from salinity are becoming very threatening. So today, nitrates, which is generally a product of agricultural or industrial wastewater, are the most common chemical contaminants in groundwater. We also see that irrigation, overpumping, and saltwater intrusion is making salinity an enormous threat to a lot of the water supply that we see in vulnerable areas. And the maps that you see here are of the Gaza Strip, where salinity and nitrates together have created a situation in which over 90% of the water in that coastal aquifer is, by WHO standards, unfit for drinking water consumption. So these other risks as well, not just household risks, but growing agricultural and salinity quality issues, are ones that we have to think about much more, particularly as the overall water quantity becomes something that is so much more binding and of such great concern in dry regions like the Middle East and North Africa. Now, a relatively new water quality challenge in this region is salinity, not necessarily in groundwater and on land, but salinity particularly in the Gulf. Desalination is an extraordinary technology and one with great promise. We've seen the cost of desalination over the last 20 or so years drop by 90%, making it competitive in some cases economically for coastal affluent cities as a drinking water supply. But what we also see is that in particular in the Gulf, where there's a preponderance of desalination opportunities, we see that the disposal of brine into the Gulf is becoming a real issue. The Gulf itself happens to be a fairly still water body, an almost closed water system. There isn't a lot of mixing of Gulf waters with, for example, the Indian Ocean. So we find that the usual dispersal of brine from desalination that we might see in other places, we don't see that level of dispersal naturally in the Gulf. Because when you use desalination, you essentially take a full amount of water, you desalinate half of it to be fresh and sweet, but the other half becomes double salty. So when that double salty brine is returned into a fairly closed system that doesn't have a lot of mixing, you end up increasing potentially the salinity levels. And in the Gulf right now, we're seeing salinity levels around 40 milligrams per liter. And this is above the level at which you want to do desalination. The more salt you have to remove, the more energy and cost it takes to desalinate. So we're getting to a point where this is really becoming a concern in the Gulf and a potential rising tragedy of the commons. It begs the question of whether we can do more science around the disposal and management of brine, whether we can do more hydrodiplomacy around an agreement for the discharge of these brine effluents into the Gulf. It's a very interesting area of great potential for science and cooperation moving forward. Another set of these challenges that we're seeing in the region, of course, is drought and flood. Flash floods are increasing rapidly, and interestingly, we were hearing this, I think, in Hangoving's presentation, that we see in cities a concentration of wealth and population. And part of the downside of that increase in wealth and population concentrated in cities is that we see concentrated risks to those populations and to those potential economic gains. So we have, in fact, since about 1980, seen a tripling of the GDP that is produced in this region that's at risk of these flash floods, particularly in these coastal cities. So the risk to economic resilience of flood is something that actually grows with wealth and grows with our thriving cities until we can make our cities much more resilient to these sorts of floods. We also see, of course, growing impacts of drought, which is a more slow-moving but very urgent area of focus. And if we try to capture specifically the impact of these water management challenges and water management practices on the environment, it's hard to capture, but a good indicator is the risk that we see to biodiversity. And what we see in this graph is some of the very significant biodiversity risks that we face that is as a result of our water management practices. Groundwater extraction, water pollution, drought and temperature extremes, the creation of dams and reservoirs that are really essential to manage the drought and flood as well. We see these together as having enormous impact on species, an enormous impact on threatened species. These are freshwater species. We see about 30% of freshwater species that are in danger of extinction in the water bodies in the Middle East, as they relate to the practices and the availability of water management in this region. So what is the overlay here specifically with the climate change impacts? I know that as the climate change debate grew, I think there was a lot of feeling in the Middle East and North Africa that high temperatures, water scarcity, this is where this region has always lived and has always managed with innovation and forethought and proactivity. But what we're seeing with climate change is an acceleration of those challenges overlaid with much larger populations and economic values at risk, and we have to be mindful of that. So here's an important graph. I think this is a graph that was that I worked on when I was at the World Bank, that tries to separate out, on the left-hand side, the changes in water stress that will be driven primarily by what we expect, that will be driven by growth and water demand of population growth and economic growth. On the right-hand side are the increases in water stress, that movement upward in water stress, that will be driven primarily by climate change. And we see that the main driver of the largest shifts in water stress in this region to 2030 will actually be climate change induced. This is not a normal increase in water stress that you see from population and economic growth that you've been living with and working for millennia in this region. What we're seeing now is that the primary driver is climate change, of these largest changes, and importantly, it's the primary driver of climate change in areas that are already environmentally or socially very fragile. That's the biophysical. Now if we look at the economic impacts that we anticipate from climate change, this was a report put out by the World Bank, a separate report that is looking at the impacts on GDP of water stress that is driven by climate change. And if we look at business as usual, this is business as usual, we're seeing large declines in GDP across all of those countries that we're looking at now. Across this, we can call it the arc of dryness. This shows you an economic scenario that the World Bank run that showed a reallocation of water resources from lower to higher value uses to try to minimize the economic impact of the water stress that will be driven by climate change. And what it shows you is that outside the Middle East and North Africa region, a reallocation from lower value uses to higher value uses will be able to essentially manage the negative impacts on GDP of climate-induced water stress. Within the Middle East and North Africa, even those extreme reallocations, they're about 30% of all water reallocated from lower to higher value uses, will still create a situation in which you'll have about a 6% or higher hit to GDP, decline in GDP from climate-induced water stress, and that's really quite serious. And then we run through the other issues, and I'll try to keep to time here. Obviously, drought increases, quite significant in a 4-degree warmer world, which we hope we never see, but quite significant, and a good reminder that we always must remain vigilant in this region in terms of drought management, forecasting, and planning. The IPCC report that came out 2 weeks ago, which has been mentioned by several others, I just want to point out one thing. What we're seeing here in these two graphs that you probably can't read from where you are, in the upper graphic, we're looking at temperature changes. In the lower graphic, we're looking at sea level rise. And what it shows you is that even if we achieve 1.5 degrees Celsius warming, which is something that would take enormous and unprecedented change in our energy mix and other practices. Even if we achieve that, we will still see a 40 centimeter sea level rise by 2100. And even if we continue with that level of warming of only 1.5%, we will by the end of the year, and this isn't written on the slide, see by the end of the century, see a 1 meter sea level rise by 2300. Because what this bottom is showing you, if you look at the gray, is it's showing you the gray bars in the bottom here show you sea level rise even if we keep to 1.5 degrees warming. The sea level rise will continue from 2100 at about a half a meter up to about 3/4 of a meter in 2200 and up to a meter in 2300, even if we can keep to 1.5 degrees centigrade. So this is a real warning call to the fact that almost no matter what our mitigation efforts are, our adaptation measures need to be strong. We also have other levers, though, to begin to address these. What are some of the responses? And I'll go quickly here because a lot of these responses have been spoken to. We have tremendous knowledge opportunities here to better understand the physical dynamics of the water system. Great Earth observation technologies, great systems management and modeling technologies that we haven't had before, and getting down to water accounting technologies, which were referenced several times in the opening ceremony previously, to understand where the water is going, what it is being used for, and how we might manage that better in the future. Because we need to understand not just the physical water availability, but the water allocation and usage, so that we understand the incentives around the water use and make sure that we're motivating conservation and allocating water to where it really needs best to be. We have growing technologies around drought monitoring and forecasting, abilities to really merge extraordinary new data streams to provide seasonal forecasts for our farmers, as well as near-time drought characteristics in terms of hydrology, soil moisture, vegetation stress, etc., to respond in a much more geographically specific way, in a much more timely way to the drought issues that we're seeing. We have opportunities not just to look at forecasting and response, but planning, the way we plan our cities, the way we plan our cities to be much more resilient, the way we can integrate. These are examples of sponge cities that are coming up around Asia, where we use much more green and gray infrastructure to integrate wetlands, mangroves, in this part of the world, sediment management, sediment flows to ensure the health of our deltas and the health of our cities. And all of that really is part of this larger shift that we need to see from the once-through thinking of the way we manage water to the circular management of water, where we close our water loops, where we reuse our water at different qualities for different purposes, at different reliabilities, closing our material loops so that we take out of sludge and wastewater the nutrients, the nitrates and the phosphorus that are useful as fertilizers, remove them from the water system where they're harmful, put them back on land where they help to replenish our soil, to close our energy loops, to capture the biogas from wastewater treatment, or to capture again those nutrients out of sludge or food waste that can be composted together to create fuel pellets and add to the fuel potential, so that we see these, what are waste streams to us now, we see them as resource streams moving forward. And specifically with regard to wastewater recycling, because there's so much opportunity here, the idea that it's a double win. We remove the hazards from our environment, and we return the water, the nutrients, and the energy safely, if we do it correctly, back to productive uses. And we're seeing phenomenal examples of that in this region and outside, to use treated wastewater to recharge groundwater, to use for industrial purposes, to grow for fodder or fiber. And in this region, and one more word there, this REE Water is a new program that will be launched on Wednesday afternoon here at 4:30. It's a partnership with IMI, with the Arab Water Council, FAO, SADARI, many other partners, to look into not only the technologies for this sort of innovation, but the institutional, the social, the cultural, and the management and financial barriers. And this is a phenomenal opportunity. We see in this region a real movement toward retreated and reused wastewater, about 18%. We see another 25% of the wastewater in this region being treated, but still over 80% not yet recycled. So where that leaves us for take-home messages is this. We know that climate change will compound all of the existing water and environmental challenges in the region, and this gives us an urgency to act. And we know that climate change in many places within the region will be the primary driver for growing water surface stress. This is important to recognize. And as the Honorable Minister said in her very astute opening statements, it's this combination of technologies and governance that we need to put ourselves on a stronger track to managing these risks. And this needs to be done, we've seen this globally, in concert, the technology and the governance hand in hand, to ensure greater resilience, much less disruption, and tremendous increased and continued prosperity in the region. Thank you very much.